Thank you so much for inviting me here, and I think I'm going to, my presentation in a sense follow up nicely to the previous presentation, but I'm focusing a little bit more on groundwater, and so I will give you a little introduction on what's Sigma. Probably everybody knows. I learned that it's not bad to hear it more than once, but what I will do is try to connect Sigma to some example of project implementation that we are doing in other agricultural areas. So this is really kind of a quick outline about an introduction about Sigma. We will talk about aquifer recharge and groundwater management recharge as a tool to support implementation. And then I will provide you with an example. We are doing some kind of actual projects in vineyards in the Casamnes River Basin, which is south of Sacramento, and I will show you how we design the project and how the project is going to be used for future Sigma implementation. As you probably know, the Sustainable Groundwater Management Act became a law in 2015, and it was due to the historic drought that we had in California from 2012, 2013 until 2015, 2016. And the entire groundwater basins in California have been divided in different priority basins. So we have medium high priority basin and overdrafted basin that must be managed sustainably. And I think what is very important and what makes Sigma different from other laws, that it's really, there is a big emphasis on local control. And the state is oversighting, but right now, I don't know, probably some of you are involved in some groundwater sustainability agencies, but right now it's more the local are getting together and trying to think about, okay, what's the plan that can help us manage our system. So the state is not yet intervening, also because all the groundwater basin have been covered by groundwater sustainability agencies in 2017, so the state didn't need to act yet. And hopefully things will be smooth in most of the areas. And the final goal of the work that the groundwater sustainability agencies are doing right now is to develop what everybody refer to as GSPs, Groundwater Sustainability Plan. And this is to give you an idea who's affected by this law. And you clearly see the maps just shows in red the basins which are overdrafted, where groundwater is being pumped at rates that are way larger than the recharge rates. And this is mainly all the southern Central Valley and some of the coastal basins. The area up here in the North Coast and the northern part of Sacramento Valley, it's mostly medium high priority basins, which are the oranges color. And the difference between these categories is the overdrafted basin need to have a plan in place by January 2020, which is basically tomorrow. So they already worked on collecting data and developing some ideas. The other basins have a little bit more time, and the plans are due in 2022. So a lot of them are really starting right now. I work with a lot of GSAs, mostly in the northern part of Central Valley, in the North Coast and up in Siskiyou County, and things are really getting started right now. What is the goal of Sigma? What is the sustainable management that we are talking so much about? Basically, the goal of Sigma is to prevent groundwater from 6 undesirable results, as they are called. And the undesirable results that Department of Water Resources define are a chronic lowering of groundwater levels over the past years, reduction of groundwater storage, seawater intrusion. Clearly, seawater intrusion doesn't affect everybody, but for some basins it is important. A degradation of water quality due to the fact that either because of the quality of water that is applied or because of too much pumping. Land subsidence, which is mainly for the lower part of Central Valley. And then surface water depletion, with the idea that when you pump from a well, which is next to a river, you are affecting the river. And so a lot of these particular undesirable results is kind of is the most difficult to really quantify, because it's difficult to really measure how much you are drawing from the rivers. And unfortunately, because of the connection with the surface water, the State Water Resources Control Board is often involved with streams, like in the Russian River, up in Northern California, like the Shasta River, and in the southern coast in the Ventura River, because all these rivers are kind of important from the State Water Board perspective on understanding interaction between surface water and groundwater. So the idea of SGMA is really to put together a plan for each groundwater basin that shows that the basin is sustainable and none of these effects is happening. If one of these effects, possible undesirable results is happening, it doesn't mean that you need to be sustainable right away in 2020 or 2022, but it's a plan. So you need to put together a sort of possible implementation strategies, and there will be a check every 5 years. So every 5 years you can demonstrate, okay, my implementation is working and my basin is getting back to sustainability, or, oh, no, things are not really going as we were expecting, we probably need to change. And as I said, the keys of the SGMA success is really that you need to develop a plan which is going to be accepted by the Department of Water Resources. That's kind of clear, because they are the ones that are going to say, okay, failed or passed. But it has to be accepted by the local stakeholders. Otherwise, the implementation will not happen. So that's why it's important that all the stakeholders can, at some point, get together and decide which are reasonable implementation plans that can be developed in the basin. So it's a lot of communication and community involvement. The plan needs to be on time. And DWR already got a request from the overdrafted basin for delaying the 2020 deadline. But no, this time they said it's 2020 for the overdrafted basin, 2022 for the other basin, and there is no extension. That's how it is. And the idea is to use, to see the positive side, and I'll talk about that a little bit more later, of this groundwater management that is now required, and see, are there tools like the database, the models, the projects that can be used, developed now and used into the future, so that it's really going to be beneficial not only for just complying with the law, but really for the management of the local basins. And this is a tool that actually, a chart that we developed together with the Farm Bureau. And I think all the county Farm Bureau, they have this brochure that you can request and go through and use for talking about how SGMA is really going to play out. And as you see, now we are at the very beginning, at the phase that it's called planning on the blue road there, the first part of the road. And so basically everybody is getting together trying to understand what can we do to demonstrate that we can be sustainable. And here, now it's really the time for everybody to engage. So in order to have a voice and really be listened by the community. The plan needs to be adopted in 2020 or 2022, depending on how critical your basin is. And then, as you see, there is every 5 years, there is a +5, +10, up to +20, is the check every 5 years to see how things are going. And every 5 years, there is a possibility to kind of adjust a little bit if things are not going as you expect they should go. And my suggestion is that I see that we are having more and more attention about these GSA meetings, and people, the locals, the farmers, they want to be involved. So if you think you might be interested depending on in which basin you are. I strongly suggest you to eventually just check it out and see if you can, at least to avoid waiting until 2022, January 30th, and the plan will be submitted on the 31st, and maybe you really don't like the plan that some other people put together. So I think it's very important to kind of at least be informed about what's happening, to avoid surprises at the end. Because maybe in some areas, maybe there is no need for a strong change in the practices, but other areas will need to come up with like smart solutions so that nobody is going to be affected significantly. And what is required in the plan, the plan requires a lot of just technical information, and which is basically what everybody is putting together now, but also requires to develop a sort of what DWR called measurable objectives and milestone to measure the sustainability of the basin. And these are the objectives that will be checked every 5 years to see if you really are sustainable and you're doing what you are supposed to do. And in terms of the technical information, the plans will contain a lot of the hydrogeological condition of the aquifer, historical and projected water demands, areas of recharge, and this is what we will be talking about later, the objectives, and then also monitoring and management plan. So some monitoring will be needed, and just to refer to what has been said earlier, it's not easy to collect interest in providing data, but at some point the data will be the good way to demonstrate the sustainability. So there is a trade-off about being anonymous and not wanting to give too much data, but it might be good in some situation. And the way I see it is that Sigma, right now everybody sees Sigma just as a big challenge because there is a lot of work to do, a lot of understanding, and I'm trying to present it in a way that says, okay, it's a big challenge, but it offers a lot of opportunities. Because of a lot of the plans that the GSAs, the groundwater sustainability agencies are developing right now, first, most of them, they are funded through grants. So the study is not really paid by the county, by the agency, or some agency they can afford that, some other, they just use Department of Water Resources money, and there will be more grants coming up. So that's why I also want to discuss about possible projects, because there will be an opportunity with a good idea to apply for grants. And I think it offers a way to just develop tools that really can be used to enhance whatever you are doing in the daily practice. So I understand right now that this need of balancing supply and demand looks challenging at this point because it has not been done in the past, at least not in this way. But I think there is nothing that anybody can do. I mean, it has to be done. So let's try to do it in a way that's going to be useful for the future. That's the main message. So which are the tools that the Groundwater Management Sustainability Agency have to really start working on the developing of the plans? Basically, the agencies are empowered to conduct studies, and right now everybody is mostly collecting data, register and monitor groundwater wells. And I want to be clear. For example, there is not really the need to measure or meter your pumping. That's not exactly what we need at this point. What we need at this point, it's actually more like groundwater elevation. How do they change? And DWR is already measuring groundwater elevation twice per year in a lot of wells all over the states. But it's not always that we need exactly like information that I think people is not confident about providing. Because as Mark presented earlier, once we have a good understanding of the irrigation practices, we can kind of over the entire basin apply irrigation rate by land use, by crop, and that's pretty much enough for what it's needed in these plants. The reports of groundwater extraction are actually right now required only in basins that are really completely unsustainable, and they are not. And it's a decision of the agency. It's not the plan that requires that. There is also the possibility to start implementing capital projects to meet the goals of the sustainability in the future. And a lot of agencies are starting assessing fees to cover cost of groundwater management. But Department of Water Resources, at least, they understood that a lot of areas are not going to be able to cover these fees. So that's why there are a lot of grants out there. And some of the requirements really do not apply to small groundwater users. So there is some kind of cutoff. So some basins, even if they use the groundwater, they didn't end up in the list and the maps that I showed earlier just because it's only few groundwater users. And what I want to talk about is now is more expanding a little bit on this idea of implementing capital project to meet the sustainability goals. And I will give you the example that we are working on. So managed aquifer recharge can really be seen as a tool to facilitate the implementation of the SGMA plans, because in a lot of areas it looks like water is available in the winter, is not available in the summer. There is a way maybe to store this water without changing pumping later on in the year. And but we need to demonstrate, if we want to do, for example, managed aquifer recharge on agricultural fields, we need to demonstrate that this water is really infiltrating, that the water is really benefiting the aquifer, and that the crops are not going to be affected, so that there will be no negative effect on whatever daily life. And which are the main gaps that we still need to cover? And there are a lot of research ongoing, but it really started recently. So there are both the scientific and technological aspects on really how do we measure where the water that gets applied on vineyards, for example, is going. And then a social aspect that people are still worried about destroying the crops, or just in basins that are where the ideal location for recharge, for example, is split between two different agencies. I see a lot of, oh, if I recharge here, I'm benefiting not my area but my neighbor, because obviously groundwater moves. And it's very difficult to say, you know, it's a win-win situation at the end. People want to be able to account for how much recharge, how much benefit is really coming to the basin thanks to groundwater recharge. And the example that I have is exactly of this type. So the Casamnes River is where we are doing one of these experiments. And we are now, I will show you later, the project is almost ready to be up and running. It took quite a while. But now we are really facing the phase of starting understanding how the system really works. So the Casamnes River is the river south of Sacramento. It's at the boundary between the South American sub-basin and the Casamnes sub-basin. Both basins are medium priority, so they are working on their groundwater sustainability plan, which are due in 2022. There is a lot of big discussion, political issues, agencies that they don't talk together because of the being split between two basins, and obviously this doesn't help. But at the same time, we hope that the project it's of interest for all the agencies, so maybe they will get together at some point in the future. And right now, the questions that I get from the stakeholders and what we are trying to answer is, where is the recharge water moving? Is moving north toward Sacramento? Is moving south toward the Casamnes sub-basin? Is it just going back to the river? Because we are recharging close to the river. And right now, really, we don't have yet a full answer. At the same time, we have a lot of group of environmentalists, and they want to understand what's the impact in the river. So is this recharge going to anyway benefit the river so there will be more fish in the fall, or it's not helping at all? Because obviously they are supporting a lot at this point, but they want to see their perspective. And then the stakeholders piece comes in, and they are asking how they can really benefit from doing all this. And some of the farmers were already counting, okay, if we recharge this much, groundwater levels will go up this much, I will save this amount in pumping. And that's the normal way of seeing it. So I really think that the energy can be a way for the stakeholders to see a very practical impact on what's happening. But then there is the sigma process. So if this is going to help with the sustainability plans, then maybe in the future there will be no need to implement other big projects. Something like this might be enough, like just to show that the system is sustainable. And then the last question is this going to impact the crops? So is the vineyards going to be impacted by the recharge that will happen? So to give you some background on the Cozumnes River, the Cozumnes rivers run dry for pretty much every year in the summer and in the late summer, sometimes also in the spring, because the Cozumnes it doesn't go very up high in the Sierra, so cannot really have a big snowpack, and there are no reservoirs. It's one of the few rivers that is not dammed, so there is no way to really store water up in a reservoir. And this is the reason why the river goes dry. There is a lot of agriculture all around the river, and sometimes that's just pictures that you can see of the river, which is running and flowing so nicely now, but unfortunately most of the summer that's how it looks like. And the profile there is kind of sometimes of estimates of how deep down the groundwater is from, and the river goes from the topography, just because of lack of water. It has been studied a lot, so luckily we have some kind of information, but what we are doing now is really trying to understand better if we can find a way to reconnect the system. Right now, just to give you an idea, the river and the aquifer they have a separation of 70 feet, something like that, of unsaturated zone, even next to the river. So there is a big possible storage. You can put a lot of water on those 70 feet. And it's 70 feet now after a super wet winter. So a lot of time, it goes easily to 100 feet. And the system recovers pretty quickly. So what you can see from some of the instruments that installed, that you can see the signal of pumping, but it goes down and comes back in just a question of a day. And this is to give you an idea of all the people involved and the agencies involved. The area where we are doing this experiment of groundwater recharge on vineyards is in the red square there. The Cozumnes subbasin is the lighter yellow, oranges on the south, and then north is the South American subbasin. And the Cozumnes is basically flow from the Sierra, and then it's entering in the Mokelumne basically at I-5. And the area downstream is all a protected area with Nature Conservancy interested in restoring some of the natural system. So what we did, we designed a system for diverting water from the river in the wintertime and using, as much as possible, using existing irrigation practices, and then just dumping as much water as possible as flood irrigation on the vineyards in the winter, and just see where this water is going. We understood that we needed to have a lot of monitoring to really demonstrate what's happening. That all this water that we are, let's say, dumping on the vineyards in January, February is going somewhere. So we installed a lot of continuous groundwater monitoring in new wells that we drilled and also in existing wells. And we are starting measuring ET and plant stress. We have an extensive modeling ongoing because, again, the idea is to use future scenarios of these managed aquifer recharge. Now we are using quite a big area, but maybe we can flood even more. But first we need to demonstrate that it works. And a lot of stakeholders are now involved. So when we started, it was difficult to find somebody who was available to give us a piece of land to try. And now things are, every time I go to a meeting and present how things are moving, what we are doing, I get somebody new that says, oh, maybe we can use a piece of my land. And so we are trying to, we are seeing that the effort, it's understood more and more, but it took about a couple of years of setting up the system. And so there is a lot of study already ongoing in groundwater recharge, flooding agricultural land. What we are talking about here is, this is just a land use map of the Casamnes area. All the light color, which on this screen they look like beige or whatever, those are all vineyards. So the area where we will be flooding is all vineyards. And more in detail, the Casamnes River is the river that flows on the southern boundary of these fields that are colored there. It's too bad that we don't have a pointer. And the three fields that will be flooded are the green field up on the northern part and the blue field on the southern part. They are pretty big because altogether is about 1,000 acres. And the overall system design is, we will be starting with the flooding next winter, so in December, because now the system is all designed. We have these pumps that take water out of the river, and in the winter they will be activated, so they will be flooding between December and February 15. We couldn't get a longer permit because of fish and biologists, so we need to stop the flooding on February 15 for now. The idea is to divert a minimum of 4,000 acre-feet per year up to 6,000 feet and just apply them on the vineyards in those basically 75 days. So it's a lot of water, but some existing measures show that there is an infiltration of about a foot per day. So it can be quite a lot. And the manager of the vineyards, he didn't seem to be concerned at all about what's going to happen to these fields, because basically these fields have always been also naturally flooded when there is a big event, and it happens. So it's not that it would not be the first time, it would not be the last one. It's a little bit more, but it's not stopping in February 15. I think that there is enough time to just bring the system back to normal. And the way it has been designed is that these vineyards are irrigated anyway mostly with surface water and on a drip irrigation system. The way we did it is there is a switch now. Basically, the water is pumped out of the river. In the wintertime, it's applied through just pipes that are along the levees and just flooded. And these will be closed as soon as February 15. So then the system goes back to drip. So this is how they did it. And the reason why the district had the money to do all this is because they applied for a integrated regional water management grant, and they got $1 million from DWR. And unfortunately, we had to go through a lot of changes in the design until we settled on something like this. But obviously, I understand that it's easy to talk about groundwater recharge, but sometimes you need the infrastructure. And it's not possible just to do it with what you have in place. We also had to double check, because one of the questions that we got from, mainly from the State Water Board is there enough water in the Kazamnes River to do that? Does it really make sense? So we had to go and check all the historical data on available surface water before really putting the system in place. And it turned out that looking at really the last about 80 years of data, 50% of the years we have enough water to divert 6,000 acre feet without impacting the river, without creating any trouble. And 70% of the years would allow at least 4,000. So this is this gave us the green light to say, okay, it makes sense to build up the project. We are doing a lot of monitoring because, as I told you, it's first required by the grant, but also it's the only way we have to demonstrate to the stakeholders that what we are doing might be useful for the future. So now the idea is that this piece of work will be used in the implementation plan, the SGMA implementation plan that the two basins are developing. We are monitoring for groundwater quantity and quality. We are monitoring for ET, soil moisture. We are also doing some kind of analysis of infiltration rates. And we really want to understand, at the end of the day, our question is, we are dumping all this water on the fields. Really, we want to be able to show the stakeholders where the water is going. Because the owner of the fields, they say, we want to understand who we are benefiting if we are not benefiting ourselves. At least if it's for the basin, we want to see what's happening. We equipped everything with telemetry because another big question that we had is, okay, we are giving you our fields and you can do your research, but we want to use this data. I mean, we want to see the soil moisture, we want to see the continuous groundwater levels so that we can adapt our irrigation using those data. So everything is up on a website, and right now only the stakeholders that are really giving us pieces of land are able to access the data, but the idea is that probably they will be open to the entire district. But basically every evening they can connect and double check what's happening. Right now, for example, because of the rain of the past days, you could see really a big raise in groundwater level just because of the rain. And because of the importance of the monitoring, we really have in the entire basin a lot of continuous data collection. And like the red points down at the bottom are in the Natural Conservancy site, so those data are public. Everybody can access those data. And the yellow one are in the South American sub-basin, mostly the city of Sacramento. And then the blue one, I will zoom in now, is really the recharge scale, the two vineyards where we are doing the extra managed aquifer recharge. And the groundwater elevation are coupled, as I said, with some soil and infiltration rate analysis. So we had, it was not expected to go in this direction, the project. So we had a lot of voluntary interest, I have to say. So for example, UC Santa Cruz decided to help us with the infiltration measurements just because they were interested in this type of project. So, and this is a good way to just increase some understanding about how we can replicate this type of project somewhere else. And so they installed temperature probes, they did soil samples, they have rain gauges, and also a continuous camera that is basically picturing the flooding, and with the idea that you can see how quickly, at least qualitative, how quickly things are changing. And as I said, this winter there was the actual extra recharge didn't happen yet, but there was a lot of natural recharge because of the amount of water that we had. And this is a preliminary map with some ideas of how things change in the soil type between the area on the eastern boundary, that is where the Kazamnes River flows, and the geology changes a lot as soon as you move a little bit farther east. And this is why we really wanted to understand how water is moving from the river toward the west. We also did stable isotopes to help us understanding which is the source of the water. And it was pretty interesting to see that in the groundwater, basically you don't see much right now. When it's we did it in the fall. In the fall, you couldn't see much of the signature of Casablanca water, but it was more of water coming from the northern South American subbasin. And that was pretty interesting. We are redoing it now because now things are completely different with all the water that is coming through the Casablanca River. And what are the expectations of on our monitoring is we hope that the infiltration should not be affected by reaction, so that between the recharge and the local groundwater. And one of the reasons is because, as I said, they were already irrigating using surface water. So they pump groundwater, but they also use surface water. So there is nothing, it's not a new type of water that we are bringing onto the vineyards. So for example, also all the questions regarding new type of bacteria, weeds, they didn't come up because it's not a different type of water. Might be more water, but not different. And we don't expect the groundwater quality to be degraded. Actually, probably it will just improve because it will be, everything will be diluted if we really can bring up the levels. So there are really, in this specific area, there are no serious concern about the quality and the impact on terms of weeds, extra work for the farmers. They didn't see anything like that up to now. So in a summary, what we hope we can demonstrate with this project is that managed aquifer recharge using, for example, vineyards in the winter can be a tool to facilitate the implementation of the sustainable groundwater management plans. And because if we can show that we can just bank and store a little bit of extra water, that might be enough in a lot of basins just to demonstrate that they are sustainable. But we understand that there is a lot more to be done to have more managed aquifer recharge example and application, because I understand we are basically working in areas where people is working for livelihood. So you are working in those farms. We are there, like in the Casablanca, we are there in the winter, and then we get out of it on February 15, but then somebody has to work on them. So it's important to understand that there are no downsides and no future problem to what's happening. And again, we really want to see if we can use this example to demonstrate that there is a bonus from the science and the technological perspective, but we can also help the GSAs working together on developing different type of projects. And I think this is pretty much my summary. So as I said, the keys to the success of the Groundwater Management Act is the local management. As I said, if you're interested and worried, go to the meetings. I strongly encourage you to do that. And it's important, the outreach and the effort on involving the community. We need good science, data collection, and again, the question before about data that needs to be anonymous, I understand that, so we are really trying to work our way around. But at the end of the day, what I tell a lot of the stakeholders I work with is data are power. If your data don't show any significant decline, that's your power for the future. So better to show them than keep them in your drawer. Just because nothing can happen if there is no significant effect. And remember that the baseline for sigma is 2015, so when things were really low everywhere. So a lot of the data I'm analyzing right now, really, I would say, I heard already stakeholders telling me, I would have not done it 10 years ago, but now I understand that if I give you this data, it's probably just going to be a benefit for me because I can demonstrate that. And manage aquifer recharge, and any other project that we can think about are type of projects that are really needed to support the groundwater sustainability agencies and the future development of the plans. Done.
Thank you.
Thank you.
We finished a little bit ahead of time, so there's time for questions. Groundwater recharge or Sigma. Oh.
Nobody wants to know anything anymore. Yeah.
You talked about the measuring the environmental, the water quality, and when you're flooding an irrigation field. Nitrogen is soluble in water, so I'm surprised you don't see nitrogen impact. That's the first question, comment. And then how about energy? Do you study the energy impact when the fields get flooded, that water's down there, now you got to pump that water back up. So what's the nitrogen environmental balance and the energy balance of this versus, say, other ways to store water?
So regarding the nitrogens, because as I said, these fields are anyway flooded more or less every winter, doesn't matter what. This will be an extra flooding. And so what they measure is that they don't think there will be any extra nitrogen that will just show up. We didn't do the extra flooding yet, so it will be measured. So we will need to demonstrate. So right now it's more like the feeling, and based on the past measurements, even with natural flooding, it looks like there is no impact. But we are counting for all the water quality measurements in as soon as we start with the actual biggest chunk of irrigation, extra irrigation this coming winter. So it's based on the perception. Right now it's based on the data that we have and the perception of the stakeholders. We will have to demonstrate that, absolutely. Regarding the energy, we didn't do much yet because right now we really don't know how this water will bank. So we have an estimate from the irrigation construction on how much this pumping, lifting this water from the river is going to cost. And it's really much less than what we were expecting. So the river, it was already, there was already a channel, a tunnel in the levee. So the amount of lifting is really limited to a few feet.
But I think he's talking about after the flooding, the groundwater level will lift. And so what is the benefit in reducing the energy used for growers?
Oh, yeah, because, basically we are thinking from our estimate is that the increase in groundwater levels can be up to 5 to 10 feet, even after the first winter. So they will be, what they expect, that's the plan, is that they will start irrigating later. So they will start pumping groundwater later, and they will pump from 10 feet higher. So just because of that, each single farmer is making its own calculation based on their pumps. And we don't have the numbers yet because, again, we still have to do the actual thing. But, yeah, and in any case, we were also trying to balance because the district was saying we have to do this project for 10 years. And anyway, we have to pay for the energy for pumping this water into the field. So it has to be a balance. The energy that they pay to lift the water from the river and the benefit they will have later because they will pump from a higher elevation. And we try to be very conservative on our estimates. I think the hope is that the recovery will be even more than 10 feet. So, and really mostly delaying by quite a bit the starting of the irrigation season. Yeah.
What would be your qualifications for a small groundwater user?
There are numbers in exempt from. It's not a single groundwater user that is exempt. It's smaller basins that are exempt. So if you are a small groundwater user in a basin where there is not much going on, there is a cutoff that now I don't remember exactly the number, but it's on the Sigma website of DWR. But it's the entire basin, it's not a single.
I have a comment. I think I see the value of integrating a data monitoring like the one showed by Mark Battany in what you guys are doing, because the before and after could be an interesting, give interesting information on how this might change the irrigation practices in the area based on the amount of water that you store in the soil, and so push irrigation forward or backward depending on the year. Because even here we got a lot of fluctuation from one year to the other. So some years are wet, some years are dry, and some years are average. So it would be interesting to integrate what Mark you're doing in that area. And they're very collaborative in that area. So me and Khaled are involved in the irrigation side, and probably monitoring the water application to be an interesting follow-up or additional data collection.
And I think that one of the good things of this specific project is really that we started like just working with the stakeholder in the district, and then a lot of people demonstrated interest, and they said, oh, I can measure that, I can offer that, I can measure that, I can offer that, because all these extra measurements were not really included in the grant that DWR gave to the district, but just because of the interest and the fact that the stakeholders, basically the land manager is opening the door whenever any of us wants to go measure something, and that changed the perspective, so that's why we have so much more going on. And we were hoping to have this year as a baseline condition, but at the end of the day, I'm not sure this winter was really a baseline condition because everything was flooded naturally. So we are kind of, it will work out. I mean, we will have anyway a lot of data. We started measuring already in 2018, so we will have continuous data for quite a bit of time. But it's true, this past winter has been a little bit unique.